Oh, we are in the second half of chapter 2 now. We're looking at applying some of these multi-step problems that we've been looking at, these multi-step equations. So we're going to look at rates, ratios, proportions. We're going to look at percents. We're going to look at interest rates. We're going to look at a lot of different things. So we're going to start with rates, ratios, and proportions. We have a little bit of vocabulary in this case. So one thing we need to write down is that a ratio is a comparison of two quantities. And we are going to do a lot of comparing. We always compare people, we compare prices, we compare things, we always are comparing. So ratios are something that people use even if they don't like math. They use ratios all the time. My wife doesn't hate math, she doesn't like math, but she uses ratios all the time. And a ratio of A to B, so teachers to students, desks to computers, whatever, can be written in a couple different ways. It can be written like this, A colon B. So if you said A to B, A, and then those two dots there between A and B is a colon, or A over B as a fraction, where B is not 0 because you can't divide by 0. We will almost always write it as a fraction. However, it could show up in other ways too. And a ratio names the same comparison. Ratios that name the same comparison are said to be equivalent. So equivalent ratios name the same comparison. We're going to look at some examples of that. That'd be like saying, if my team has 2 wins and 5 losses, that's the same as your team that has 4 wins and 10 losses. It compares the same comparison, same ratio. So 4/6. We're going to start by looking at this ratio. So that's a ratio, 4/6, 4 out of 6, 4 wins, 6 losses, 4 wins, 6 games. We can reduce fractions. We've done that before. So we can reduce 4/6. We can do divided by 2, and then we'd say that's the same as 2/3. So 4/6 is the same as 2/3. 4 wins to 6 games is the same as 2 wins to 3 games. It represents the same thing. And so we could say that 4/6 equals 2/3, and those are equivalent ratios. You could do the same way this way and say times 2, times 2. You could say 8/12 is the same as 4/6, which is the same as 2/3. And we can use that to help us solve some problems. So here's an example. I've got 4 over x. We don't know what x is. Equals 2/3. We can work with, that's the same thing, in fact. Look at that. I know that 4 divided by 2 is 2, and some number divided by 2 would have to be 3. X would have to equal 6. We can use this idea of equivalent ratios to help us solve problems if the numbers work out well together. Since 4 divided by 2 is 2, I know that since these are equal fractions, they're equal ratios, some number divided by 2 has to be 3. Well, 6. X has to equal 6. We've got our answer. So if the numbers work out well, that's all we have to do is think about it as equivalent ratios, equivalent fractions, reducing fractions. Let's look here. Is there a nice number that we can do either 3 times something equals 5? No, not really. How about 5 divided by something equals 3? No, not really. I'm sure there's something in there, but there's nothing nice that I can come up with off the top of my head. There is another way that we can solve this. We call 2 equivalent ratios that are right next to each other like that with an equal sign a proportion. And you looked at proportions last year in 6th grade. One way to solve a proportion is to do what we call cross multiplying. So cross multiplying is saying that if we do 3 times 1, so I'm going to write it out here, 3 times 1, that's the same, or that's equal to 5 times whatever this is here, x. 5 times x. Well, 5 times x, that's just 5x. So I'm going to get rid of the times there. That's just 5x. And 3 times 1, well, 3 times 1 is just 3. Okay. So if I want to solve for x, I just have to divide by 5. I've got my answer, 3/5. 3/5, which really is, what, 0.8. So 0.8 divided by 3, sorry, 0.6. 0.6 divided by 3 is equal to 1/5. But if you can't find a nice number, another way to do it is to cross multiply and then divide to get x all by itself. So what I'd like you to do is I'd like you to practice this cross multiplying. You did this last year, but you maybe forgot how to, maybe forgot about it. You're going to multiply at a diagonal across that equal sign. This only works with a proportion where there's an equal sign. 3 times 1 was 3. 5 times x was 5x. And then to get x by itself, we divided by 5 to both sides and got our answer. So try this one, see what you get. I'm assuming you tried it. I'm assuming you either paused it or you tried it and you did it quickly. So if you cross multiplied and you divided correctly, you should get that w equals either 27/5, and you just left it as 27/5, or you could have written that as 5 2/5, or since we can use calculators in this half of the chapter, yes, we can use calculators now. You could have certainly done 5. What would that be? 5.4. And any of those would have been acceptable. Oh, if you didn't get that, watch the linked video. Whew, that's bigger. That's a bigger proportion. So there's a couple ways we could do this. We could think about it back to the original idea of equal fractions, and that it would work that way. Well, let's use this cross multiplying method that we have. So I'm going to do 12 times 8. I'm going to get 96. And I'm going to do 1 times x plus 10. But I'm going to write that out. 1 times x plus 10. And you'll notice I put that in parentheses because when we have more than one thing in the bottom of a fraction, it's like having parentheses. It's a grouping. So it's 1 times x plus 10. In this case, if we distribute that 1 through, it doesn't really change anything. So I can distribute, though, and say that 1 times x and 1 times 10, we end up with just x plus 10. So that didn't really affect it. But if it was a 2, instead of a 1 here, if this was a 2, or a 3, or a 4, or pretty much anything other than a 1, we would have to distribute that through. Now I solve, I can minus 10 from both sides, and 86 equals x. So cross multiplying, when there's more than one thing, you're still doing the same stuff. You're still doing 12 times 8, and you're doing 1 times whatever's down here. Just be careful that if there's more than one thing, it's like having parentheses. So those parentheses matter now, because we're going to distribute through the parentheses and get our answer. Try this. Try g plus 3 over 5 equals 7/4. Cross multiply and divide. Remember your parentheses. Pause it. Try this on your own. I'm assuming you tried it. I'm assuming you did it on your own. You either got that g equals 23/4, or you got that g equals 5 3/4, or if you use a calculator, 5.75 would be our answer for that one. If you didn't get one of those answers, which really is all the exact same answer, watch the linked video. Okay, I'm moving on because it's a long video. There's a lot of notes here, and we'll do a lot of practice with that cross multiplying in class too. A rate. A rate is a comparison of two quantities, a lot like a ratio, except this one, a rate has units. The difference is, if we have a ratio of 4 to 6, we don't know what they're talking about. It could be wins and losses, wins and games. It could be sheep and shepherds. We don't know. And so an example then, what I'll have you write down, a ratio is 90 to 3. That's a ratio. It's a comparison of two things. A rate has some labels. Now we know that it's 90 miles in 3 hours. That's a rate. So the only difference between a ratio and a rate is that a rate has units. It has a label. So we actually know what we're talking about when we say 90 and 3. A little more vocabulary. A unit rate is a rate in which the second quantity is 1. So an example of that is most people don't talk about how fast they're going and say, I was going 90 miles per 3 hours. This is not how we talk about speed. 90 miles per 3 hours, well, 90 miles, I lost my pen. 90 miles in 3 hours. That's the same as 30 miles in 1 hour. That's much more common. If you're going down Bridge Avenue at 30 miles an hour, most people don't say, yeah, I was going down Bridge at 90 miles per 3 hours. That's just not our common way of comparing things. So a unit rate has a rate where the second quantity is 1. All right, so Jeff. I know it looks like Geoff, but it's actually pronounced Jeff. I had a friend in high school. Sorry, I had an acquaintance in high school, and he went by, and his name was Jeff, but we sometimes called him Geoff. He was a friend. He can type 30 words in half a minute. Let's start with that. 30 words in half a minute. So I'm going to label it, because it's a rate, words. And he could do that in half. Calculators like decimals, so I'm going to go ahead and put 0.5 minutes. Labels are going to make a huge difference in this chapter, and I am going to start grading labels. And so we need to make sure we're practicing with labels. So 30 words in half a minute. We want to know how many words can you type in 1 minute. So here's our question. Our question is, how many words, we don't know, X words, in 1 minute? Well, it's a proportion. We can solve a proportion. Now, there's a couple ways we could do this. You could cross multiply and divide. That would work. Or, if I can figure out 0.5, a half, times something equals 1. 2 halves is 1 whole, so I know that 0.5 times 2 would equal 1. That means that since these are equivalent fractions, equivalent ratios, 30 times 2 would have to be 60 words. So my solution, how many words can he type in 1 minute? He can type 60 words per minute. 60 words per 1 minute. And if you cross multiplied and divided, you would have gotten the same result. I just looked at it as 2 equivalent fractions. But the idea of this unit rate is we're given some rate to start with, 30 words in half a minute. You set that up as a ratio, 30 words, 0.5 minutes. And then there's a question, how many words can you type in 1 minute? So how many words, that's where I had my X words right there. I'm putting a lot of markings on this. And 1 minute, there's my 1 minute. And then we compared and tried to find our answer. I'd like you to try this one about Penelope. Penelope can type 90 words in 2 minutes. How many words can she type in 1 minute? Don't just write the answer, because I'm going to expect you to be able to show me how you got your answer on a test. Even if you can figure it out in your head, being able to express how you got that answer in your head might even be harder than figuring out the answer. But try it on your own. Again, I hope you practiced showing how it's set up. The correct answer is 45 words. Oops, words, there we go. That says words. It looks like, but it's words. 45 words in 1 minute. Now, if you don't know how to set that up, you just knew what the answer was, watch the linked video so you can at least see how you're supposed to set it up. A map. We like maps. Helps us find our way. And so a map, oh, I'm going a little bit long here, has a scale of 1 inch to 18 miles. We're going to stop right there. Stopping point. That's a scale. That's a rate. I've got a rate, 1 inch compared to 18 miles. That's a rate that we can work with. On the map, the distance from Chicago to Evanston is 0.625 inches. Now, of course, the actual distance is not going to be 7/8 of an inch. That's not how far apart Chicago and Evanston are apart in the real world. So we have to figure out what the actual distance is. In my rate here, I put the inches on top and the miles on the bottom because they came, inches was first, miles was second. So when I write my second ratio, the one that I say I don't know how many miles apart they are, I have to make sure that I put the right number in the right spot. Inches are on top, miles are on the bottom. If on the map it's 0.625, 7/8 inches, then I want to make sure that I match those up. I want to be consistent and say I went inches to miles, inches on top, miles on the bottom. I want to go inches on top, and I don't know how many miles on the bottom. So those labels really come in handy when we're trying to set up our problems too. When we're trying to set up those problems. Well, we cross, multiply, and divide. I'm going to use a calculator at this point. You could certainly work it out with fractions and change 0.625 to 7/8 and then do times 18. But I'm going to do 0.625 in my calculator times 18, and I end up with 11.25. So I cross multiplied here. And I know that 1 times x is just x. I got my answer. I do need to label it 11.25 miles, because there's a big difference between 11 miles and 11 inches. So 11.25 miles is the correct answer. What I'd like you is I'd like you to try this one, set it up with a proportion, and figure out the distance on the map from Chicago to Waukegan. All right, I'm assuming you paused. I'm assuming you tried it on your own. The distance on the map, so it's 1 inch to 18 miles is still the scale. The distance on the map for a 4-mile trip is going to be 1.43 inches. If you didn't get that answer, make sure you, oh, no, I apologize. I'm sorry, I was thinking about the wrong one. Woo. Some of you are freaking out or thinking I did it wrong. Nope, sorry. Round your answer to the nearest tenth. The ends up being 0.2 miles, or inches. Been a long day. Inches. Distance on the map, rounded to the nearest tenth, 0.2 inches for that one. I'm going to stop there because I've already made some mistakes, I think. Yeah, I'm going to stop there. And I'm going to go ahead and say, try the questions after this video, and we'll keep working on this in